Here is your warm-up for today. Please pause the video right now and give everybody a chance to solve. And then when we're ready, you can unpause and I'll go over it. Okay, so this tells us that the distribution of heights of students in a class is roughly normal, and that the average height is 68 inches. We're not given the standard deviation, but we are told that 95% of students' heights are between 62 and 74 inches. So I'm going to draw a normal curve that has a mean of 68. And then I know that 95% of heights are between 62 and 74. What you need to do is think about how many standard deviations out we have to go to capture 95% of students' heights. And hopefully you knew that that was 2 standard deviations. So that means that the distance from 68 to 74 was 2 standard deviations, and the distance from 68 down to 62 was 2 standard deviations. Now, since for both of these, this is a distance of 6, that means 1 standard deviation must be half of that, and I get B, which is 3. Okay, so today what we're going to learn is how to use z-scores backwards. And what I mean is, given a percentage or given a proportion, we want to find what observation would put us in that top however many percent or that bottom however many percent. And we're going to use those tables that we learned how to use with the forward z-score problems, but we're going to use them backwards. And so our general strategy is going to be to find the requested area in the table, in the guts of the table, and then locate the corresponding z-score. So I want you to look at this first question. What z-score would put you in the bottom 22%? Okay. Now remember, percentages are in the guts of the tables. So you're going to get out your tables, pause the video if we need to take time to get out the tables. Okay, and we know that the tables give us the area to the left. So let me draw a little picture here and shade in the bottom 22%. And I'm going to shade over here because 22% is less than half. And I want this area over here to be equal to 0.22. Okay, now I'm going to get out my tables. And I'm going to look in the guts for the closest thing I can find to 0.22. And look along with me in your tables. I see, it's kind of hard to find. I see that I'm getting close to 0.22 right around over here. And I see this guy right here, 0.2206, is the closest guts value I can get to 0.22. Once I find that, I can kind of circle it or highlight it with my finger, and I can trace to the left, and I see negative 0.7, and I trace up, and I see 0.07, and I know that if I put those together, I can form a z-score of negative 0.77. So, let me bring back my PowerPoint. Uh-oh. And I know that this gives me a z-score of negative 0.77. Okay? So a z-score of negative 0.77 puts me in the bottom 22%. I know without even thinking about it that I should get a negative z-score here because I know that negative z-scores put me below the mean and positive z-scores put me above the mean. So since I'm in the bottom half, I know I'm going to have a negative z-score. Let's do another example. I want the top 12%. So I'm going to draw my normal curve, and I'm going to shade in the top 12%. And I want you to remember that the tables only give me the area to the left. This has given me the area to the right, 12%. So real quick, think about how you would find which area it is that we're actually looking for in the tables if I want the top 12%. Well, saying the top 12% is the same as saying the bottom 88%. Do you agree? Since the total area under the curve is equal to 1. So I'm not going to be looking for 12% in the guts. I'm really going to be looking for 88%. So let's go back to our tables. And I'm looking for the bottom 88%. Now on the first page, notice this is the page with the negative z-scores. This only goes up to 0.5. That's because this isn't going to give me a negative z-score. This is going to give me a positive z-score. I'm going to have to go over to this page to find 0.88 in the guts, because since I know I'm in the top half, I'm above the mean, I know I'm going to have a positive z-score. So search in the guts and find the closest thing you can to 0.88. Okay, I actually see that it's exactly between two values. This isn't going to let me highlight that, but it's exactly between 0.8790 and 0.8810. So I can kind of choose either z-score or I can average them together. Regardless, I trace over and I trace up to put together that z-score. So if I trace to the left, I'm at 1.1. If I trace up, I'm at either 0.07 or 0.08. So that gives me a z-score of 1.17 or 1.18. 1.17 or 1.18. Or if I wanted to average them together, I can call it 1.175. Any of those would be okay if we're solving a problem. Okay, I want you to pause the video right now and try to do these last two, the bottom 15% and the top 25%. Okay, so go ahead and pause the video, bottom 15% and the top 25%. Okay, for the bottom 15%, let's pull back up my tables. First of all, think about if this is going to be a negative z-score or a positive z-score. It's going to be a negative z-score because if I'm in the bottom 15%, that means I'm below the mean. And I look in the guts for the closest thing I can find to 0.15. And I believe it is 0.1492. Okay, you may have seen this 0.1515, but 0.1492 is actually closer. Okay, so I'm going to trace over and up, and I see negative 1.04. Negative 1.04. Okay, for top 25%, that's the same as saying the bottom 75%. So when I go to my tables, I'm actually going to be looking at the positive z-score side because I'm in the top half, and I'm looking for the closest thing I can find to 0.75, which is 0.7486. That's a little bit closer than the ones on either side. So that's going to give me a z-score of positive 0.67. Positive 0.67. Okay. Now, we can put these problems in context as well, okay? Just like when we learned the forwards z-score problems, we can do backwards z-score problems through this four-step process. And it's going to be kind of backwards from the process we did before. Step 1 is going to be to state the problem and draw a picture. Step 2 is going to be to use our tables. Step 3 is going to be to unstandardize, meaning go from a z-score back to a value in context. And step 4 is going to be to write our conclusion in context. So using the same IQ example that we did yesterday, IQ scores are normally distributed with a mean of 110 and a standard deviation of 25. I want to know what score places people in the top 10% of IQ scores. Okay, so we've stated the problem already. We can draw a picture. I want the top 10%, which means I want the area to the right to be equal to 0.10. Now ask yourself, am I going to be looking for an area of 0.10 in the tables? No, because the tables give me the area to the left. So I'm really going to be looking for 0.90 in the tables. Okay, so I'm going to pull up my tables. And I'm looking for the closest thing I can find to 0.90. And I see 0.8997 right here. Okay? I'm going to take that 0.8997 and trace that to the left and up. And I want you to see what z-score you get. I get a z-score of 1.28. 1.28. So I'm going to bring this back up. I get a z-score of 1.28. Now remember, this isn't a percentage. The percentage that we found was 90%. That was given to us in the problem, okay? This represents a z-score. Someone who has the top 10% of IQ scores is at least 1.28 standard deviations above the mean. So I'm going to unstandardize. I'm going to go from a z-score back to a value. Now you need to think about the formula for a z-score, which is x minus the mean over the standard deviation. So this is x, the actual IQ score, minus the mean IQ score, which was given to us as 110, divided by the standard deviation of 25. And what I'm going to do is solve this for x. I want you to pause and do the algebra here. Solve this for x. Okay, to solve for x, I'm going to start by multiplying both sides by 25. And when I multiply 1.28 times 25, I realize that I don't have a calculator in front of me, so hang on just a second. Okay, 1.28 times 25 gives me 32. And these 25s cancel out, and I'm left with x minus 110. Now I'm going to add 110 to both sides. And I get x is equal to 142. So to put my conclusion in context, it says what score places people in the top 10% of IQ scores? So a score of 142 or higher places people in the top 10%. And the reason I said or higher is because if somebody has a score higher than 142, they're still in the top 10%. All right, so what we did is we drew a picture. We used the table to find the z-score that corresponds to the percentage that we were given. We un-z-scored it, so we went from z back to x. And we wrote our answer in context. Okay? Here's another example. It says the length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with a mean of 266 days and a standard deviation of 16 days. How long do the longest 20% of pregnancies last? And what about the shortest 15% of pregnancies? Okay, let's do the first one together, and then I'll have you pause and do the second one by yourself. So the longest 20% means I'm going to shade where? I'm going to shade the top 20%. However, can I look up 20%? No, I'm actually going to be looking up 80%. Okay, so I'm going to go back to my z-score tables, and am I going to be looking for a positive z-score or a negative z-score? I'm going to be looking for a positive z-score because this right here is above the mean. I'm above the mean. So let's go back to our tables, and I'm looking for 80%, and the closest one I see is right here, 0.7995, which if I trace over and up gives me a z-score of 0.84. So I know z is equal to 0.84. Now, unfortunately, when I do this, it keeps making my drawings go away. You really should have the drawing on the page as part of your answer. Okay? Now I need to unstandardize. This is going to equal x minus the mean, 266, over the standard deviation, which is 16. Last thing I need to do is solve for x and write my answer in context. So I multiply both sides by 16. And this gives me 0.84 times 16 is 13.44. And that's equal to x minus 266. I add 266 to both sides. And I get x is equal to 279.44. So my answer in context, a pregnancy must be 279.44 days or longer to be in the longest 20%. Okay. All right. Now, what about the shortest 15% of pregnancies? How long does a pregnancy need to be in the shortest 15%? Please pause the video right now. Help each other with this. I want you to go through this entire example by yourself. Okay, let's go ahead and start by drawing our picture. Shortest 15% is over here. Okay. I don't need to subtract it from 1 because this is already a left area. This is already to the left. And I also know that this is going to be a negative z-score because this is below the mean. Shortest 15% automatically puts me below the mean. So I'm going to be looking for 0.15 in the guts. Let's pull up our tables. I'm going to go to the negative z-score side. And I'm looking for 0.15 in the guts. And I think we did this one already. It's 1492 is the closest. So I'm going to trace over and up, and I get a z-score of negative 1.04. Negative 1.04. So shortest 15%. Z is negative 1.04. And I'm going to set that equal to x minus the mean, which we're given, over the standard deviation, which we're given. And I'm going to solve for x. So I'm going to multiply both sides by 16. And that gives me 16 times negative 1.04, which is negative 16.64, equal to x minus 266. I'm going to add 266 to both sides, and I get 249.36. So a pregnancy must be 249.36 days or less to be in the shortest 15% of pregnancies. Okay? Hopefully we got through that example okay. I just want to take a second and review the difference between a forward z-score problem and a backward z-score problem. So a forward z-score problem is going to be you're given the observation values and asked to find a percentage. So it says the student heights at this school have a normal distribution with a mean of 66 inches and a standard deviation of 3.2 inches. What percent of people will be between 60 and 65 inches? So I'm given the values of 60 and 65 inches, and I'm asked to find the percentage. In contrast, a backwards problem, same situation as last slide, same height distribution. What height puts people in the top 25%? This time you're given a percentage and asked to find the observation value, asked to find X. So I'm going to ask you to go through both of these and then we'll go over them. So let's go back to the first one. We have heights are normally distributed with a mean of 66 inches and a standard deviation of 3.2 inches. And I want to know what percent of people will be between 60 and 65 inches. Pause and solve this. Okay, so the first thing I need to do is find the z-scores associated with this problem. For 60 inches, the z-score is going to be 60 minus the mean divided by the standard deviation, which gives me negative 1.88. The z-score associated with 65 inches is going to be 65 minus the mean divided by the standard deviation. So that gives me a z-score of negative 0.31. And I'm going to draw my picture. So negative 1.88 is going to be somewhere over here. Negative 0.31 is going to be somewhere over here. And I want the area in between them. Now I need to look up both of these z-scores. And what am I going to do? I'm going to subtract what I find. Okay? So I'm going to look up negative 0.31. And I'm going to look up negative 1.88, and I'm going to subtract what I get. Remember, this is a forward z-score problem. So I'm going to go to the tables, and negative 0.31, negative 0.31 gives me 0.3783. And negative 1.88, negative 1.88 gives me 0.0301. And so when I subtract those, I get 0.3783 minus 0.0301, which gives me 34.3482. So putting it in context, I would say 34.82% of people will be between 60 and 65 inches tall. Okay? Looking at this backwards one, again, I'm normally distributed with a mean of 66 inches and a standard deviation of 3.2 inches. Is that right? Yep. And we're asked what height puts people in the top 25%. So I want you to try this one as well. Go ahead and pause the video and solve this. Okay, so I'm going to make my normal curve. I want the top 25%, which I know I cannot look up in the table. What I'm going to look up is the bottom 75%. Okay, this is going to be a positive z-score. So I'm going to my positive z-score page, which is the second one. And I'm looking for the closest thing I can find to 0.75. I believe we've looked this one up as well. It ends up being 0.7486, which I need to make into a z-score. So I'm going to trace left and up, and I get 0.67. 0.67. So z is equal to 0.67, which is going to equal x minus the mean divided by the standard deviation. I'm going to solve that for x. And I get 68.144. My conclusion in context is that a height of 68.144 inches or taller would put someone in the top 25%. Hopefully these two were okay. All right. So here is homework assignment number 4. You can go ahead and get started on that. There is a quiz tomorrow on both these forwards and backwards z-score problems. Okay. On Monday, we are going to do AP practice and some review, and your test is on Tuesday because we are already done with this chapter. Okay. Thank you.